There are stars that are literally the size of solar systems. So the more massive the star is, a star, let's say 10,000 times the mass of the sun, then it has to burn its fuel extremely quickly to stay up against the force of gravity. So they're very, very, very short-lived. The really massive stars in the universe, I don't know the figure for the biggest star, but the one of the biggest you can see with the naked eye actually is Beetlejuice, or Beetle in Orion. And what's interesting about that is if you put it where the Earth is, then it would extend out pretty much to the orbit of Jupiter. I think even beyond the orbit of Jupiter. So if you imagine how far it is to Jupiter, that would be orbiting inside the star. And it's so big that we can see sunspots on the surface with telescopes here on Earth. So it's a vast star. That's a star at the end of its life that's swollen up. That isn't, however, the biggest. We can look so far out into space that we can see the light from just after the Big Bang, about 3 to 80,000 years after the Big Bang, actually. And in that light before there were stars and galaxies. There are also patterns that match onto the way the galaxies are distributed in the sky today. And where did those patterns come from? Well, the best theory we have is a theory called inflation, which says that before Big Bang, in the sense that before the universe was very hot and very dense, it was still there and it was kind of cold and empty, but expanding very fast. And then that very fast stretch of the universe came to an end, slowed down, and in the slowing down, the universe got heated up and all the particles out of which the stars and galaxies are made were created. So that's called inflation. There's good evidence for that. Mars is the only planet we'll colonize beyond Earth, but it's an easy planet to colonize. It's got water in abundance below the surface, we're sure, or frozen in the ice caps. It's got all the minerals that we need to build a civilization. We have the technology to go and extract the water and turn the water into oxygen and hydrogen for us to breathe and to make rocket fuel and electricity, all the things we need to build a civilization. So we know how to do it. So it's just whether we want to or when we want to. Most of the plans I've seen to go to Mars involve setting up the base first with robots and then going to the base. So it's almost we build the base first and then we go and move in. And I think that's what we're going to do.